Today we will take implicit functions and derivative of implicit function and that of inverse trigonometric functions. Inverse trigonometric functions, trigonometric functions. Okay. See, first let us clearly understand that what we mean by implicit function. I will take one example here given in your book itself, and that is x plus sine x pi xy plus minus y is equal to 0. And then I will take another example, that is y is equal to say sine of x plus x square. Now see, these are two examples where in the former case see y has been expressed clearly in terms of x. Clearly in terms of x. This implies that y here is explicitly expressed in terms of x. But in the case of this second example, this is your first example, see, such a thing is not happening. Such a thing is not happening. Till the methods you have read, you cannot explicitly express y as a function of x. For the simple reason that here it is sine xy and you don't know any of the methods such that this y can be segregated from this term sine xy. Now the question is that whether y do depends upon x or not, how we will come to know about it. That this y, will it depend on x or not? So answer obviously is yes, it do depends upon x, for the simple reason that see, here if we assign certain value to x, suppose x has been assigned value, say 0. So this equation becomes sine y minus y is equal to 0 or sine y is equal to sine y. Y is equal to sine 0 because x into 0 will make the whole thing 0. So this will give you y is equal to 0. Now see, if here in this equation, if I put x is equal to say pi, then let us see what the value will be. Then I will get pi plus sine x into pi, okay, minus y is equal to 0. Okay, so what does it mean? At place of x, I have written pi, please see, and at place here I will write y. So sine y into pi, basically it will be like this. Okay, so here see what you will get. Y will be equal to what? Pi plus sine pi y. This is at the best what you will get here. Now, so point is, what the value of y you are getting? It is pi plus sine pi y. This point needs to be understood. Here I will not give x value pi. I will give x value pi by y. So pi by y, as soon as I keep it, so what I will get? It will be pi plus sine pi. So y will be equal to what? Sine pi is again 0, so it is pi. So what I am getting is that when I am putting this value, x is equal to pi upon y, then what I am getting? Y is equal to pi. When I kept x is equal to 0, then the value of y turned out to be 0. So similarly, see, if I, just now you have seen that if I put x is equal to only pi, then what will be the value of y? It will be simply pi plus, you put it, pi plus sine, at place of x you put pi y, and minus y is equal to 0, giving you what? Y is equal to minus y is equal to pi, this thing I am taking this side, pi plus sine pi y. Now here see, in order to solve this equation, see again you will be in a problem because directly you can't get value of from this expression of y, because here itself y is given. Y has to be given some value. So still see that solution is coming. But in the earlier two cases, when you were giving the value x equal to 0 or pi upon y, then of course what you have seen that value was differing, clearly indicating that y do depends upon the function x. And see, one thing is explicit here, that y, the value of y will not depend on any other factor apart from x. The only question which we need to see here is that whether this value of this thing, this y, whether it depends x on x or not. So clearly see, we are seeing that when we are changing the values of x 0, y was 0, when x is pi y, then it is again pi plus sine pi 0, that is pi, and when it is pi, then it is pi plus sine pi y. So here see, still now you still have not been able, in the third case see, still you have not been able to find the value of pi, of y, because here you had to do some other analysis. So what best we can do here is that see, we there will be certain other way outs, numerical methods through which we will try to find out, but till this the method which we have learned up to this stage, see, it is almost impossible to find the value of y from this particular equation. But see, our main point and concern was whether see in the implicit function y, this other variable, will it be depending on the first variable or not. See, normally you will be getting like this equations. So this is what we had to accept is, yes, it do shows that y will do depend upon x. And whenever see we have this sort of equation, then we will see how we can find the derivatives. So I will quickly take one or two examples. So in this see, for finding the derivative of an implicit function, what you will do, you will assume that yes, y is some function of x. You will keep in mind, say y is some function of x. Now this precisely you don't know. It can be imaginary function or whatever. But one thing is there, yes, y will do depend upon x. And then with this assumption in mind, see, we can do the problems. See, I forgot my duster. Let me quickly bring it. Yes. So we will take few questions here from your this 5.2, and then we will see how we can find this questions therein. I am taking this first example, very easy. It is 2x plus 3y is equal to sine x. So here see things are sine x. Now here see things are simpler because it is sine x, so no issues. So 3y will be equal to what? Sine x minus 2x, and y will be this thing 1 by 3. So here it is not the case of implicit function, it is the case of explicit function. So you won't have any trouble. Dy by dx, of course, see, you know 1 by 3 you will differentiate this thing. So cos x and minus 2. So no example. This was your question number 1. It is not the case of implicit function. It is the case of this thing. So we will. But see, same thing here in the question 2. They have done the same thing. 2x plus 3y is equal to sine y. Now this is a question where you can't do it. Here see, no way you will be in a position to find y. You can directly write y in terms of x. So what you will do, you will assume that here let y be some hypothetical function which precisely you don't know, that is of x. Okay, so what we need to do is, we will differentiate this whole thing with respect to x. We will differentiate this entire equation with respect to x. So what it will give me? It will give me d by dx of 2x plus d by dx of 3y and d by dx of sine of y. Now students, please do remember that now this thing you can easily differentiate because constant you can take out, and d by dx of x is 1. D by dx of, see, I will tell you the correct procedure how to write it. Here you can take it out and you will write dy by dx. And here see, this is a function of function. You will invoke the chain rule formula because y you are assuming to be a function of x. So what you will do, you will write d upon dy sine of y and into dy by dx. Because what you do, you will put this y as internal function, and then see, this thing, your function sine y is your this thing. So first you will differentiate with respect to internal function, and that internal function is being differentiated with respect to external function. Okay, so either you put y is equal to t, and then see you can write d upon dt of sine t and dt by dx. So that t, instead of putting t, because this is a straightforward, you are putting it t is equal to y. So that's why you are writing d upon dy sine y. What is y? Y is your internal function. So the chain rule formula simply tells you that first you differentiate the external function with respect to internal function, and then differentiate internal function with respect to independent variable x. So this is 2 into 1 plus 3 dy by dx. See, this method you know, you can write by y dash is equal to what? D by dy of sine y is cos y, and then this is y dash. Now terms containing y dash you bring on the one side, so take it on the other side and take y dash common. So what you will get? Cos y minus 3, and therefore y dash will be what? It will be 2 upon cos y minus 3. So this is how you will be doing. See, there is hardly anything difficult in this thing. Only the thing is that you have to bear in mind that yes, what we are doing, that we will assume in these cases of implicit expressions that y to be some function of x, and then with this assumption in mind we will differentiate it. Let us take one or two more examples here of your grip. And now question number 3, let us do it. And then it is question 3. Please see, they are very simple. Ax plus by square is equal to cos y. Again here see, you won't be able to express y directly in terms of x. So what you will do here? Differentiate the entire equation with x. So what you will get is d by dx of ax, okay, plus d by dx of by square, and it is d by dx of cos of y. Okay. So a is constant, can be taken outside. So what you will get? Dx upon dx plus b is constant, could be taken outside of the derivative sign. So it will be d by dx of y square, and this is d by dx of cos y. So it is invoke the chain rule formula, d upon dy cos y into dy by dx. Okay, same thing. So it is a into 1 plus b, d upon dx of y square. Please make it. Again see, y is a function of x. So it will be what? You have to first differentiate with y, and then y square you will write dy by dx is equal to derivative of cos y with respect to y. It is minus sine y into dy by dx, that is you can write it as y dash. So it is a plus b. Now d upon dy y square is 2y, and this is dy by dx is your dx is equal to minus sine y into y dash. Now terms containing y dash you keep it at one place and take common from there. So I will be putting this thing and taking the other side and take y dash common from this term and this term. After transposing it on the left side, what I will get is 2 by from here, and here it will be plus sine y within brackets is equal to minus a. So y dash will be equal to what? Minus a upon this whole thing within brackets 2by plus sine y. Plus sine y. Just let me take one phone call because इट इज हाँ अजय जी, मैडम ये सब सामान एक्चुअली में जाएगा म्यूजिक रूम में। अभी आप उसे खाली करवा दीजिए और ये जो सामान लाए हैं लैंग्वेज लैब का, इसको उसमें अंदर पहुंचवा दीजिए। हाँ करवा दीजिए। Sorry for interruption. Yes, so this is how we would be doing it. Now, next question, and then we will take your this derivative of inverse function. Few more questions we will do it. Okay. Next question is question number 4. It is now see xy. Question 4. It is xy plus y square is equal to tan x plus y. Tan x plus y. Okay. So what we will do? Adopt the same theory. You differentiate this entire thing with respect to x. So d upon dx of xy. See, it is a product rule. Plus d upon dx of y square is equal to d upon dx of tan x plus dy upon dx. Please see, you know that if there are number of terms, then the derivative of the sum of all the terms is equal to the sum of their individual derivative. So we are justified in writing the individual derivatives. Now it is the product rule. Here first function, second function. So you will employ the product rule here. First function into derivative of second function dy by dx plus second function into derivative of first. So this is how you will get the derivative of this part. Plus d upon dx of y square, since y is a function of x, so what you will do, you will invoke the chain rule formula, you will write dy by d square into dy by dx is equal to d by dx of tan x, no issue, it will be sec square x straight away, and this is your y dash. Now please see, this is what x into y dash plus y into 1 plus 2y y dash is equal to sec square x plus y dash. So let us see where are the terms containing y dash. 3 terms, rest of the term we will shift and we will take y dash common. So from this term x will come common, from here what will come common? 2y, and from here what will come common? 1. And rest of the term we will transpose on the other side, that is it will be equal to sec square and then minus y. So y dash, that is dy by dx, it will be what? Sec square x minus y upon x plus 2y plus 1. So that is your answer. This is how you will be doing it. Please, it may appear simple to you right now, but this is the procedure, correct procedure. Please develop the habit of doing it with the correct procedure. Otherwise, see, at times you will get confused and you will commit a mistake. So this is how we can do it. Okay, let me take one more question here quickly. Question number 7. Okay, let me take 6th here. It's a big one. X cubed plus x square y plus xy square and plus y cube is equal to 81. So here see, you had to find the derivative of y. So dy by dx, let us see how it is. Is it visible, sir? Bhavi sir, visible at the top? Okay. So this is the problem. So what you will do the same thing, differentiating the entire equation with respect to x. So what it will be, d by dx of x cubed plus d by dx of x square y and plus d by dx of xy square plus d by dx of y cube and is equal to d by dx of 81. So what it is? D by dx of x cube will give you what? 3x square plus d by, this is the product of two functions, first function and second function. So what it will be? First function into derivative of second d upon dx of y plus second function y into derivative of second d by dx of x square. And likewise this is also the product of two functions. So we will invoke the product rule here. So what it will be? First function into derivative of second d upon dx of y square plus y square into d by dx of x. This is the derivative here. This is the derivative here. Plus d upon dx of y cube. So what is this? Y is a function of x. So it is 5x whole cube. Function of function. So what you will do? Internal function. That is 5x. You will put y. You will put something. So let y be y, and then this y cube be differentiated with respect to y. So d upon dy y cube into dy upon dx, and this is 0 because this is a constant function. Now this is 3x square, put the value x square, dy by dx we will put y dash plus y into 2x plus x into d by dx of y square. Again you have to do the same thing. It is to be written as dy by y square into dy by dx. dy by dx. Please see, derivative of this thing will be now this thing, because you are differentiating y square with x. So first see, you will have to differentiate with respect to y, and then y is to be differentiated this thing plus y square, and this dx by dx is 1. So I will keep this thing in bracket plus dy, this is 3y square and y dash. Now rest all we have already simplified. It is 3x square plus x square y dash plus 2xy plus, let us see what it is. This is giving me x, y square dy is 2y, okay, and 2y into y dash plus y square into 1 plus 3y square y dash. Let us see where y dash are coming. Here. In 3 terms y dash is coming. So we will keep all these terms at one place and we will take common. So here y dash I am taking common. What I will get? X square from here. What I will get here? I will get 2xy here. And then what I will get here? It is 0, 3y square from here. And this is y dash I have taken common, the value of which I had to determine. And then rest of the things I will keep at the one place. And let me take it on the other side. So this 3x square transpose on the other side will give me minus 3x square. And then this 2xy taken other side will be giving me 2xy. And then this term y square will also give me y square. And what else? That's all. So if I take minus sign common, so these two will become plus. And so y dash value will be minus 3x square plus 2xy plus y square whole upon this thing, x square plus 2xy plus 3y square. So this is the answer. This is the derivative of this thing. So this is how you would be doing it. Please make sure that here see at times you may have a confusion. That is like d by dx of y cube. See, I am doing it like this, like d upon dy y cube into dy by dx. But then see, you may have a little bit of confusion in understanding the things, because what you had been doing in the chain rule, you had been deliberately putting the internal function y is equal to some variable t, and then you used to differentiate the external function with respect to t, and then t was to be differentiated with respect to independent variable. So see here, what do you see? If you assume, see, I will tell you, you will get the same answer both the ways. This point needs explanation, and this is, I think, must be causing you a certain amount of confusion as well. So I will find the value of this d in both the ways, and you will see that the result turns out to be same in both the situations. See, d upon dx of y cube, and here what is y? Y is some imaginary function of x. So effectively what it is d by dx of 5x whole cube. See, this is what you had to find it out. Now see, if I write in this particular manner, so what I am doing is I have put y equal to 5x. In fact, see, why some a little bit of confusion is there, because had it been written in this particular form, then you would have been smart enough to put 5x to be t, because 5x here is clearly visible that it is an internal function. And then see what you would have done, you would have kept 5x is equal to t, and then d by dx of, you would have written t cube, and then see you would have written d by dt of t cube and dt by dx. So answer would have been what? 3t square into dt by dx. Dt by dx will come from here, and 5x is nothing but y. So dt by dx is what? It is, because you don't know what is 5x, so it will be d by dx of 5x, and 5x is what? Y precisely. So it is dy by dx into this is your dt by dx. So here you will put dy by dx, and at place of this is 3t square, at place of t what you will put? 5x, and 5x is what? Y square. So 3y square dy by dx, this is what you get by this particular method. See, only this much of thing is there, but the same result I was not doing this way. I was not putting y to be equal to 5x, and that's why see you was having a little bit of confusion that why I am not putting internal function is equal to 2. Yes, I could have put it like this, if I put y is equal to 5x, and then see if I understand it, then of course it will go this way. In fact, I should have done it this way to make you explain. But see, the same result, if you are assuming that y is a function of x, then you are what you are doing, you are now, second method how we are carrying it out is like this: d by dx y cube. Okay, here see, if I know that y is a function of x, then what I will do, I will this y 5x cube, so 5x will be my internal function as you have seen here. So my y, and then see this 5x, y is equal to 5x, see what you have put it, y is equal to 5x and 5x is equal to t. So y is equal to t, basically y is equal to t only. So this is what needs to be done. So if I am making an assumption that y is equal to 5x, some function, then what I will do? So I will first of all differentiate it with y, and then this y is to be differentiated with respect to independent function. So instead of doing this long process, I have cut short it, and this answer you will be getting this particular way also, dy by dx. This is 2. Please see 1 and 2, they are giving you the same thing. They are giving you the same thing. So please, you have to by doing a little bit of practice and pondering over that, yes, why it is becoming so, such and such. So whenever you encounter this implicit sort of things, then of course you have to be careful. Yes, that explicitly it may not appear at the first moment that yes, it is a function of function, but yes, it is a function of function. Then only you can do it. Okay. Now I will take one more. Okay, now let me go for the inverse function theory, because you can now do it. And if any problem, we will let you know later on. Okay, now let us see how we can find the derivatives of the inverse function. So the very first inverse function is y is equal to sine inverse x. How? Let us see, learn today that how we can find the derivative of this sine inverse x. Okay, so what I can well write it to be what? This can be well written to be x is equal to sine y. This can well be written to be what? X is equal to sine y. Now, what I will do? I will differentiate this equation with respect to x both the ways. So it will be d upon dx of x is equal to d upon dx of sine y. Assuming that y is a function of x. So it is a function of function. So what I will do, I will write it, it is pcy only. And then what I will do, this y I will put, y I will assume, y is my internal function. So first of all, see this external, and sine is what my external function. So sine y upon dy into dy by dx. And then see this internal function has to be differentiated with respect to independent variable x. So this is how the chain rule has to be invoked over here. D upon dy sin y is what? Cos y, and dy by dx is y dash, and this is 1. So cos y, this thing, y dash is nothing but 1 upon cos y, and then sin y is x. Please see, one thing I would like to first of all make you very cautious here, that here see the derivative will not exist when cos y is 0. Cos y is 0 when y, y becomes pi by 2. Or minus pi by 2. Minus pi by 2, of course, because when you are taking sin inverse x, then y, what is the value of y? Y will lie between this thing, minus pi by 2 to minus, x will lie between minus 1 and 2 plus 1, and this will lie between minus, closed interval minus pi by 2 to plus pi by 2 to both the values. So here x, see here y, if it becomes minus pi by 2 or plus pi by 2, then see this will not be defined. This will not be defined. So this point you have to bear in mind, that the derivative of this function, inverse function, will exist only in the open interval minus pi by 2 to plus pi by 2, not in the closed interval. This is one thing which, of course, see, you need to understand for better in-depth understanding of this thing. And then see, rest of the single, sin y is equal to x. So what you can write, cos y is equal to what? Under root 1 minus sin square y, and then this is what? 1 upon under root 1 minus sin y is x, so it will be x square. So derivative of this function sin inverse x is nothing but 1 upon under root 1 minus x square. It is easy to remember that if the derivative of sin inverse x is this thing, then what you will find that this thing, the derivative of cos inverse x will be minus 1 upon under root 1 minus x square. Likewise for tan inverse x and cot inverse x. And then for second, this thing, cos also, cosec also, you will find the same thing happening. Just see, y is equal to, suppose, I will quickly show you also, y is equal to, suppose, cos inverse x, its derivative has to be found. Then what you will write? Cos y is equal to x. Differentiate this thing with respect to x. So d upon dx cos y is equal to d by dx of x. So what it is, d upon dy, you will invoke the cos rule into dy by dx is equal to 1. So dy upon dy of cos y is what? Minus sin y. So this implies y dash I am writing from here, like here, y dash is how much? PC, this is dy by dx is y dash, and d upon dy of cos y is what? Minus sin y. So 1 upon minus sin y. And then please see, cos y is x. So sin y will be what? Minus 1 upon under root 1 minus x square. Because sin y will be 1 minus cos square. So see, derivative of sin inverse x is this thing, then the derivative of cos inverse is this thing. Likewise, we will find the derivative of tan inverse to be 1 upon 1 plus x square, and we will show the derivative of cot inverse x is 1 upon 1 plus minus 1 upon 1 plus x square. Likewise for second, cosec. Their derivative will be differing each other by only a negative sign. So now I will take the derivative of, yes, tan inverse x, or okay. So y is equal to tan inverse x. Now here what you will do, yes, you will write as usual x is equal to tan y by definition. Differentiating it with respect to x, what you will get, dx upon dx is equal to d upon dx of tangent y, and then this thing can well be written to be d upon dy tangent y into dy by dx. So it is 1 is equal to, and then see this part, it is sec square y tangent y into y dash. So y dash effectively is what? 1 upon sec square y, and sec square y what you can well write to be, sec square y is 1 plus tan square theta, so it is 1 plus tan square y, and then see what is tan y is x, so what it is 1 plus x square. So this is the derivative of this thing, tan inverse x, it is y dash dy by dx of tan inverse x is nothing but 1 upon 1 plus x square or x square plus 1. The same thing. So similarly, see, it's quite easy to show that the derivative of cos inverse x is cot inverse x will be minus 1 upon 1 plus x square. Now we will take the derivative of sec inverse x and of cosec inverse x, we can take it and we will show that yes, it is yes. So y is equal to sec inverse x, let me take it, its derivative we have to find it out. So what I will do, I will again write x is equal to sec y, and then it is like this, that we will differentiate this thing with respect to x all the way. So d by dx of sec y, which will be equal to d upon d by sec y and dy by dx. dy by dx. So it is 1 here. So 1 and sec y derivative is what? Sec y tan y and y dash. So value of y dash is nothing but 1 upon sec y tan y, and put the value of sec y is x and tan y is under root what? 1 plus, 1 plus tan square theta is equal to sec square theta. So here tan y is under root sec square theta minus 1 sec square theta minus 1. So it is 1 upon x under root x square minus 1. X square minus 1. This is the derivative of sec inverse x y dash is equal to how much? 1 upon x under root x square minus 1. So this is, and then derivative, likewise derivative if y is equal to cosec inverse x, then you can show that y dash is equal to minus 1 upon x under root x square minus 1. So these are the standard formulae, you have to remember it, and based upon this thing, see, we will try for certain questions here, and here see your knowledge of trigonometry. Trigonometry will also help you a bit. So this thing you had to take care. I will take few examples from your book here. First is yes, y is equal to sine inverse 2x upon 1 plus x square. 1 plus x square. Now see here two ways of doing this thing. Two ways of doing this thing. One is that either you put this whole thing is equal to t. See, I will tell you the first method. It is, you put t is equal to how much? 2x upon 1 plus x square. And then see, invoke the rule. dy by dx, what it will become? It is sine d by dx of sine inverse t. And then for it is d by dt of sine inverse t, and this is dt by dx. dt by dx. And sine inverse t is what? 1 upon, you have already seen that it is 1 upon under root 1 minus x square. 1 minus t square, and dt by dx you will find from here. dt by dx you will invoke what? Quotient rule. 1 plus x square whole square, denominator square, denominator into numerator minus numerator into derivative of denominator, which is 2x. So this is dt by dx. So let us solve a bit. Let us see what it gives us. So it is 2x plus x square into 2x cube minus 4x square minus 4x square upon 1 plus x square whole square. So this is what we will substitute at this place. But before that we had to calculate the value of t as well. So this is a lengthy calculation, we had to do it. 1 minus t square. T square is what? 2x square upon 1 plus x square whole square. Let us simplify this thing into dt by dx. We will put this much of thing. That is what it is. It is 2x plus 2x cube minus 4x square up whole upon 1 plus x square whole square. And then see, we will simplify this thing. Let us see how it comes out. Let us take LCM here. I am rubbing it here. So, yes. So what it will give me 1 upon within square root. Yes, what is the LCM? 1 plus x square whole square and then 1 plus x square whole square minus 2x whole square into this whole lot. This in fact is this thing only. 2x, I shouldn't have simplified it, then I would have got my answer. But anyway, 4x square upon 1 plus x square whole square. Now please see, this 1 plus x square whole square, that will go up, and outside the under root sign what I will get is that I have to check it. It will be 1 plus x square. See, outside the root, and it will go on the top upon under root this thing 1 plus x square whole square minus 4x square into this lot 2x plus 2x cube minus 4x square upon 1 plus x square whole square. This we will be getting it. And please see that here this entire lot will cancel. This thing and this thing on simplification will fetch you same thing, and this one will cancel, and eventually you will be getting only 1 upon 1 plus x square. This is how you will be doing it. But then there is a very short method for doing it that I will tell you. But see, you will try both the method. This is the basic method, and that shortcut method that you can employ only when you have done all these things a good amount of practice. So here, see, I will tell you how you will get the same answer by doing this thing. Sine inverse 2x upon 1 plus x square. And see, in all the questions, you see this technique will certainly be there. Now what I will do is, here, please see, that here I will put x is equal to what? Tangent theta. Why I am putting this thing? Because I know 2x upon 1 plus x square, this will be 2 tangent theta upon 1 plus tan square theta, that is sec square theta, and this is 2 sine cos, and this is nothing but 2 sine theta upon cos theta, and this sec theta, and this 1 sec theta will go upward, and this is your sine 2 theta. Sine 2 theta. So this basically becomes what? Sine inverse, and this whole lot becomes sine 2 theta. Sine 2 theta when you put x is equal to tangent theta. When you put x is equal to tangent theta. Okay, so this is simple. Now, y is your simple. Sine inverse sine 2 theta is 2 theta only. And then see, dy by dx, you have to determine. So what you will do, you will write it dy by dx of 2 theta. And this thing you can well write to be what? Twice d by d theta, dx of theta. And for calculating this d theta by dx, what you will do? You will come here. It is theta is what? Tan inverse x. So d theta by dx is what? Just now you have seen it is 1 upon 1 plus x square. So it is dy by dx is equal to 2, and d theta at place of d theta you will put 1 upon 1 plus x square. Please see. So this is the answer. See, in the earlier case you were getting only 1 plus x square, 2 was missing. Please see that there was a mistake. You calculate it both the ways, and then see, you will find that it is coming the same answer. The first method will also, because 2 I skipped somewhere, it was a mistake. So this is how you would be saving your much time. But then one more, I will be requesting you to do it completely by the first method as well, all the questions. Because your questions here, they are simple, provided your trigonometry is good. Question number 10 I am taking, you have to find y is equal to tan inverse 3x minus x cube upon 1 minus 3x square. 3x square. Again see, here if x is tangent theta, then 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta is nothing but the expansion of tangent 3 theta. So we will make use of that thing. So what we will do here, we will put x is equal to what? Tangent theta. Put x is equal to tangent theta. So y will be equal to what? Tan inverse 3 tangent theta minus tan cube theta upon 1 minus 3 tan square theta. And then this is nothing but tan inverse tangent 3 theta. And this is nothing but 3 theta only. So now things become very simple. Y is equal to 3 theta. So dy by dx. Now see, please don't differentiate with theta. You have to differentiate with x only. So this is d by dx of 3 theta. And this is nothing but 3. You can take constant, can always be taken outside the derivative sign. D theta by d x, and this is what? 3 d theta by dx. That is yes, d theta by dx, which can further be written to be what? D by d theta of theta into d theta by dx. Okay, chain rule you will do. So this is 3 into 1, and d theta by dx you will improve from here because theta is what? Tan inverse x. So d theta by dx will be nothing but your 1 upon 1 plus x square. So this is 3 upon 1 plus x square. This is the answer. This is the answer. So this is how you would be doing it, these types of questions. And I will take a few more questions here for your convenience, and I would be requesting you, but see, please try the question by both the methods. Okay, now here, question number, okay, look in, let me take here question number, okay, 10 we have done, 11th. 11th again simple, y is equal to, yes, cos inverse 1 minus x square upon 1 plus x square. So here see again simple, put x is equal to tangent theta. So this thing is will give you what? Cos theta. Put x is equal to tangent theta. You have seen all these expressions. So 1 minus x square upon 1 plus x square, what it becomes? 1 minus tan square theta upon 1 plus tan square theta, which on simplification will sin upon cos. So cos square theta minus sin square theta upon cos square theta, and this is nothing but cos square theta plus sin square theta, whole thing upon cos square theta. This goes, and this is 1, and this is what? Cos of 2 theta. So if this you put here x is equal to tangent theta, so y becomes what? Cos inverse cos of 2 theta, and this is nothing but 2 theta. And then see dy by d theta is what? Dy by d theta is nothing but 2. No, you have to differentiate with respect to x. Please don't differentiate with respect to theta. Y is a function of x, so you have to differentiate with respect to x. So it is 2d d by dx of theta. This again you have to write d theta upon d theta into d theta by dx. And the value of this thing is what? 2, 1, and d theta by dx you will determine from here. Because theta is what? Tan inverse x, and as in the earlier case, d theta by dx is nothing but 1 upon 1 plus x square. So put this value, you will get 1 upon 1 plus x square as answer. So now see, so you have to be this way, you can do very easily. I will take one more question today, and this question, let me see, cos inverse is okay. Let me take this question 30. Here see again you have to be a bit intelligent. Y is equal to cos inverse 2x upon 1 plus x square. Now see here, you have to use the property of this thing, inverse trigonometric function also, because here you know if you put x is equal to tangent theta, then do 2 tan theta upon 1 plus tan square theta is what? 2 tan theta upon 1 plus tan square theta, and just now you have seen that it is 2 sin theta upon 1 plus sec square theta and cos theta sec theta, and once this sec theta is cos theta, so it is sin 2 theta. It is sin 2 theta. So y is equal to what? It is cos inverse sine of 2 theta. Now please see. Now if you want to further simplify it, then what you can do? Now cos inverse of some function is what? It is pi minus sine inverse sine of 2 theta. This property you will use, and immediately now it will be pi minus 2 theta y. So dy by dx, now it is simple, it will be d upon dx of pi minus d upon dx of 2 theta, and this is 0 minus 2 d theta by dx is what? Again you have to rewrite as d theta by d theta into d theta by dx, and this is what? Minus 2 1 into d theta by dx. X is equal to tangent theta, so theta is equal to tan inverse x, and just now you have seen that it is nothing but 1 plus x square. So this is the answer. This is the answer. So today I stop here. As a matter of fact, I wanted to take another important topic, that is of the logarithmic function and this exponential function, and so that will be my next topic, and I will be taking it on my scheduled time. So thank you, students. With the hope and expectation that you will try as many questions as there is, and please see, do ask also. You can switch on your this microphone, and then you can ask questions from me as well. Any question, please do ask, or else we will stop it. I will be posting my video by evening. Thank you.